Today we're going to talk about quadratics, and we're going to talk about two different ways that you can write quadratics and how they change how you would go about graphing your parabola. Now, if you're looking for more of an Algebra 2 type video graphing parabolas with the directrix and the focus and stuff, this video is not for you. We're going to be sticking with the axis of symmetry, the x-intercepts, and the vertex as your main points to graph for today. So let's go ahead and get started. The first thing we're going to talk about is the standard form for quadratics, which is in the form ax squared plus bx plus c. You can also see the notation y equals ax squared plus bx plus c. And more than likely you're going to be seeing f of x and y used interchangeably, and that's fine. They're just different notations for essentially the same thing. So here's a graph, and let's go ahead and draw a parabola on there. So when we're talking about quadratics, we're always graphing a parabola. So when we talk about the vertex, which is this point approximately right here, it's always that point on the parabola when it's about to change. So notice it's going up, or excuse me, it's going down, 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 and right before it's about to go up, back up again, that's where your vertex is. And in order to solve for your vertex, we use an equation, negative b all over 2a, and that's going to get you your x value of your vertex. And to get your y value, I like to just denote it as f of x for this particular problem, because what we're going to do is we're going to solve for our x, we're going to substitute it back into our original equation, and that's going to give us our y. Now, before we move on to the next form, we also have something called the axis of symmetry, which goes, it's a vertical line for the purposes of this video, and it goes straight through that axis of symmetry. So if you were to fold my parabola, maybe not this specific one, but if you were to fold a perfectly drawn parabola straight across that axis of symmetry, it would lay directly on top of itself. And in order to solve for this axis of symmetry, we're going to actually solve for it exactly the way we do for our x value of our vertex, because again, it goes straight through that vertex. So our axis of symmetry, and to find it again, x equals negative b over 2. And that would be the equation, because notice we have a vertical line, so we have a undefined slope, so we have the equation x equals some value. So those are how, using an equation in the form ax squared plus bx plus c, how you would graph the main points of a parabola. We'll get into a couple of specific examples in the next video. But first I want to show you one more form, and let me get my blue pen back. So we're going to look at forms and they're in the factored form. I'm just going to use y equals, and we're going to have a x minus p x minus q. So notice this is something that would already be factored. So if it was already in its factored form, this is how we would solve for it. So again, you could denote it with f of x or y. Okay, and a, p, and q are just numbers. The x's are obviously going to stay x's because we need those for our equations. Okay, so again, here's just a quick graph. Here's our parabola. Now, and let's go ahead and get labeling. So here we have our these are our x-intercepts, both of these points here. Okay, and depending on what p and q are, one is going to be p comma 0, and the other is going to be q 0. Because remember, anytime we have an x-intercept, our y value is always 0. Now when we're talking about our vertex here, instead of using our negative b over 2a, because notice we don't have a b or a c value in this particular form of the equation, we're going to say x equals p plus q all over 2. And that's going to get us our axis of symmetry, and then we take that value and substitute it back in to find our y value. In the next video, I'll show you some specific examples. Thank you for listening.